Let's try this again with another function. Y equals 2x squared minus 4x, leave a space, minus 3. This time we do have a leading coefficient of 2, which we need to factor out of the first two terms. So y will equal 2 times the quantity x squared minus 2x, leave a blank, close parentheses, minus 3. We do not divide the 2 out of the negative 3 because we've closed the parentheses and the 2 can't reach over that far. Now we will cut the negative 2 in half to negative 1, square it to a 1, and again, we need to look at this value. We're not going to be adding this to both sides of the equation. That it really isn't even a 1. That's a 2 because the 2 distributes to the 1. So we've added 2 to the right. We now need to subtract that 2 back off. So completing the square, we will have x minus 1 quantity squared, a 2 out in front, and combine these values at the right to get minus 5. And we can easily identify the vertex to be at positive 1, negative 5, and we get that positive 1 by changing the sign of that negative 1 that's coming out of the parentheses. To identify the x-intercepts, we always want to set y equal to 0. And I'm going to go to the completed square form. 0 is equal to 2 times x minus 1 squared minus 5. I need to solve for this x, and I'm going to begin by adding 5 to each side. That will give me 5 equals, and let's divide by 2 at the same time. 5 halves is equal to x minus 1 squared. Now we want to square root each side. Now that's going to give us the square root of a fraction, and we're going to want to rationalize the denominator by multiplying by root 2 over root 2. This will give us the square root of 10 over the whole number 2 is equal to x minus 1. I've already square rooted, I should say, so I should have a plus or minus on the left. And now we are going to add 1 to both sides, and that will give us 1 plus or minus the square root of 10 over 2 is equal to x. Now this can be written as 2 over 2 so that we can combine it as a same fraction, or we can leave it as is here. So the x-intercepts will be at 1 plus or minus root 10 over 2, comma 0. To identify the y-intercept or intercepts, let's look at the original equation, y equals 2x squared minus 4x minus 3. This minus 3 gives everything away. We would be setting x equal to 0, which would zero out these first two terms, and y would equal negative 3. That tells us that the y-intercept is at 0, negative 3. So now let's sketch this function. Let's plot that y-intercept of 0, negative 3 that we just found. Let's plot the vertex at 1, negative 5, which we found earlier. We know by symmetry we're going to have another value right there at 3, negative 3, or 2, negative 3, and we can go in and we can draw this graph right now. Now I'd like to look at these x-intercepts really quickly. Let's go back up to what we had. The square root of 10, you know, is a little bit more than 3. Dividing by 2, we have a little bit more than 1.5. So 1 plus 1.5-ish is 2.5-ish. Look at our graph. Does that appear to be right around 2.5-ish? And then if we go 1 minus 1.5-ish, I get negative 1/2. And that appears to be right around where this x-intercept is, and that's consistent with that ugly irrational number we found earlier. To determine the axis of symmetry, that will just be that line going through the vertex. Since it's vertical, it's of the form x equals, and it will be x equals 1 because 1 comma negative 5 was our vertex. Because this graph opens upward, it's going to have a minimum value. So the minimum value here is going to be negative 5. The domain is going to be all real numbers, and the range will begin at -5 and include that value and go on up to positive infinity.